for this oscillator, if we ignore RC, just consider input here and output here, you can calculate the closed loop gain as this one. But if we consider ZP is the parallel, RC parallel, and this one is ZS is, so parallel Z and serial Z, RC serial, RC parallel Z. We have ZS and ZP. If you consider these two, you can derive the transfer function of this one, and you can get the loop gain L for the oscillator. Derive this one. Okay, so please do the closed loop gain first. After that, add these two and do the, okay, this is the transfer function without ZSZP, and then get the transfer function with ZS and ZP. They prove the loop gain L equal to this one. Then simplify this one into this one. Then LS here. Eventually you can get this one. And you can replace S by J omega. So we can get this one. Okay, everyone, please. Okay, if you reach this one, this is the loop gain. So in order to have oscillation, loop gain should be equal to 1. Then the loop gain will be a real number. Because 1 is a real number, there's no imaginary part. Then, so this one must be 0. This is the imaginary part. So this one must be 0. So we can get this result. Omega 0 is the oscillation frequency. Then we can get the result here. Kyler, could you read this?
To obtain the sustained oscillations at this frequency, one should set the magnitude of the loop gain to unity. This can be achieved by selecting.
Okay, so loop gain L should be 1 to make sure we have oscillation. So beta A should be equal to 1. Then if this one is 0, then this one equal to 1, then R2 divided by R1 should be equal to 2. Hugh, do you agree with me?
Yes.
Good. So we have the ratio. So that's why I tell those electrical guys, for any circuit you select to do, you should have mathematical equation and the relation, the ratio, to help you to do your design, to select the RC value. This is important. Okay, exercise. Kumil, could you read the problem statement?
To ensure that oscillations will start when choose R2 by R1 slightly greater than 2, the reader can easily verify that if R2 by R1 is equal to 2 plus
Delta.
where delta is small number, the roots of the characteristics equation 1 minus L of S is equal to 0 will be in the right half of the S plane.
Okay, thank you. So this is the loop gain. So if we choose R2 divided by R1 equal to 2 plus delta. Delta is a small positive number. So we can replace this one into this one. Then solve for the equation. Then you can prove the roots of the characteristic equation is on the right hand plane, means it has a real part, and the real part is greater than 0. Okay, please do this. Camera off. Is everyone finished? Hugh, have you finished?
Yeah.
because for the oscillator to operate, we need to have okay. Armin, could you read this?
Magnitude of oscillation can stabilize by using a nonlinear control network of the symmetrical feedback limiter.
Okay, we have a limiter. 3, 4, 5, 6, and diode. So they will help the oscillation to stay, won't get too large, and won't get too small. Okay. Okay, read the first one, please.
At the positive part of the output voltage VO, the voltage at the node B will establish the voltage V1, which is about VO divided 3, and dot D2 diode D2 conduce this will cap the positive part peak to the value determined by R5, R6, and the negative power supply.
Okay, so this is the negative power supply. Remember, the positive peak of the output voltage VO. If the output gets too large for this oscillator, if VO is too large, then V1, see the ratio, this is 20, this is 10. 1 plus R2 divided by R1 is 3. So the ratio between VO and VI is 1:3. So let's find VI is equal to VO divided by 3. And D2. So if VO get too large, B will be large too. Ignore this one. Just look at this voltage divider. If VO is large, VB will be large too. If VB is large, V2 conducts. So this one is, suppose there's no current, just goes through this one. This will claim the positive peak. So this positive peak will be determined by R5, R6, and minus. See, if this is minus 1,5, this is R6, this is R5. Then the positive peak will be determined by this value. See, the drop for D2 say 0.7 volt, and this is V1. V1 plus 0.7, then VB is fixed by V1 plus VD2. So if VB is fixed, we have R5, R6, and minus 1,5 volt. We can determine the VO this way. And Kyler, could you read this?
And writing a node equation at node B while neglecting the current through D2.
Okay. So if we ignore the current through D2, then we can write down the voltage VO. Okay, please write down the voltage for VO based on this one, this one, this one, and VB. VB equal to this one. Okay, camera off. Okay, Kumil, could you read this?
Yeah, the negative peak of the output sine wave will be clamped to the value that caused diode T1 to conduct. The value of the negative P can be determined by setting VA equal to V1 minus VT1 and writing an equation at node A while neglecting the current through T1.
Okay, so the same situation. If VO now goes to negative peak, negative, then this one will become more negative. So this one will conduct, and this one will off. So if this one conduct, you can write down VA as V1 minus VD1. So you get voltage here. Assume there's small current, very small, very tiny. So you can ignore the current here. So no current here. All the current comes from this, goes down to this point. So the current through R1 should be the same as the current through R4. So this way you can write down VO. Okay. Yeah, before we continue, I'd like you to look at this. For mains engineer, so the salary looks like 60K, 77K, 83K. So this mains engineer. For ME semiconductor, the equipment maintenance engineer, usually the mechanical engineer from this department, most of them go to those semiconductor industries. They just maintain the machinery, and their salary looks like just stay 50K, 60K for several years. So looks like not very good. But for analog engineer, see, they got 97K, 84K, 78K, 1 year, 3, 5. So analog engineer in Taiwan, they usually get high salary. So that's why there's a future for analog engineer. But for mains engineer, if you can do, somewhere between, you got high salary. So for them, although Professor Yang also tell them, 3 years, but you can get good future. It's worth it. Okay, just to give you some idea about the future possibilities. So for mains engineer, it's also much better than mechanical engineer. So it will hurt to learn something about circuit. Okay, you have practiced already, so you must have the ability to do this. Kaiser, could you read this?
Show that to obtain a symmetrical output waveform, R3 is chosen equal to R6 and R4 equal to R5.
Okay, you have done the VO, the high value and low value. So you got 2 values, but you want them to be symmetrical, means they have the same magnitude in positive and negative. In order for VO to have symmetrical output, prove R3 should be close equal to R6 and R4 should be equal to R5. Okay. Okay, could you read this?
For the circuit in the figures 17.5, A
Disregarding.
disregarding the linear circuit, find the location for the closed loop pulse. And B, find the frequency of the oscillator. C, write the limit in place, find the amplitude for the output signal view. Assess that the diode don't in 0.7 V.
Okay, A. So this is the limiter. The limiter. So remove the limiter. So this is the RC oscillator. Find the location of the closed loop poles. So you can get this is VO, this is VI. You can get a transfer function. And the pole is the denominator. You set the characteristic equation denominator equal to 0, you can get poles. Then you can find, if you get the transfer function, you can find the frequency of oscillation for this circuit. So that's A and B, and C with the limiter circuit. Then find the amplitude of the output sine wave. Assume D1, D2 drop in 0.7. So you can get the peak to peak. You can get the high, the positive and the negative. Because you have practiced that in those sections. So you know you can use those equations to get the maximum value of VO and minimum value of VO. The maximum minus minimum is the peak to peak voltage output. Okay, start please.